One of the special angles in trigonometry is the 45-degree angle. So it is imperative that we must familiarize ourselves with the trigonometric functions of a 45-degree angle. To find the trigonometric functions of 45 degrees, we construct an isosceles right triangle. So this is an isosceles right triangle. There. Let us first identify the properties of an isosceles right triangle. So first, it has a 90-degree angle. Yeah. So this is the 90-degree angle, angle C, and the side opposite the 90-degree angle will be the hypotenuse of the isosceles triangle. Yeah. Another property of an isosceles triangle is that the other two sides are congruent. So A is equal to B. And correspondingly, the two angles are also congruent. The other two angles are also congruent. So angle A is also equal to angle B, and their measures equal to 45 degrees. So this one is equal to 45 degrees, and so is angle B. Okay, so that if you add the three angles of the triangle, that would sum up to 180 degrees. So we now try to get the functions of 45 degrees. So again, let us write down our mnemonics, SOHCAHTOA, to help us recall the ratio or definition of each of these trigonometric functions. S stands for sine, C for cosine, T for tangent. Okay, let's start by giving a particular value to sides A and B. Say A is equal to 1 unit. Since A is equal to B, then B is also equal to 1 unit. And with these values given, we can get the value of C by, so get C by using Pythagorean theorem. Pythagorean theorem. And Pythagorean theorem states that the square of the hypotenuse, so C squared, is equal to the sum of the squares of the other sides. So A squared plus B squared. And A is equal to 1 and B is also equal to 1. Simplifying further, we get 1 times 1 is 1 plus 1 times 1 is 1. So we'll get C squared is equal to 2. 1 plus 1, 2. Then we get the square root of both sides of the equation. So this cancel each other out, leaving only C, and C is equal to square root of 2. There. So we now have a value for the hypotenuse, When A and B is equal to 1 unit or are equal to 1 unit, then C is equal to square root of 2. Since all of the sides of the isosceles right triangle are already, or each of the sides is already known, we are now ready to get the trigonometric function. So let's start with the sine. We consider angle A. Actually, we can consider either of these two angles. But let's just consider angle A, which is equal to 45 degrees. So we say sine of angle A, or 45 degrees, is equal to the opposite from saw. Opposite over hypotenuse. The opposite of side of 45, this 45 degree angle is 1. And the hypotenuse is square root of 2. So we can simplify this by removing the radical sign below by multiplying the numerator by the denominator as well as the denominator. And we will have here square root of 2 over 2. Or we can use our calculator to get the sine of 45 degrees. So what is the square root of 2? So this is our calculator. Okay, we get the functions there, square root of 2. Okay, that is equal to 1.414. So square root of 2 is 1.414 divided by 2. Then, so sine of 45 is equal to, so let's divide this by 2, and that will be equal to 0.707. So this is now the sine of a 45 degree angle. Then for letter B, we take the cosine of 45 degrees. Cosine of 45, ka, adjacent over hypotenuse. The adjacent is 1. So 1. And the hypotenuse is square root of 2. And you will notice that the sine of 45 degree angle is the same as its cosine there. Because these two angles are complementary angles. Okay? So we can immediately say that the cosine of 45, because if we simplify this further, we will be coming out with the same value there. So this is now the cosine of 45 degrees. To get the tangent of 45 degrees from TOA, opposite over adjacent, the opposite of 45 is 1. And over the adjacent, this is also equal to 1. So tangent of 45, 1 divided by 1 is equal to 1. So the tangent of a 45 degree angle is equal to 1. That will be our third function. Fourth function is cosecant 45. That is the inverse of sine. So we invert this. It will now be square root of 2 over 1. So CSC of 45 is equal to square root of 2. And what is square root of 2? This is square root of 2. That is equal to 1.414. Yeah. So this is the fourth function of 45-degree angle. So it follows that the second of 45 is the inverse of cosine. So we will just invert this. Square root of 2 over 1. Or that is also equal to square root of 2. And that is equal to 1.414. And lastly, the cotangent of 45 degrees is equal to the inverse of tangent. So we invert that, we have the same 1 over 1, and that is equal to 1. There. Okay, so this is the fifth. This is the sixth. So these are the trigonometric functions of the special angle 45 degrees. I hope this video help you understand this lesson. And thank you for watching. Have a good day.